Good morning, all of you. Welcome to C J in the Rank Zone. Now we are into the last lecture of S block elements. In this lecture, we are going to learn about alkaline earth metals and some important compounds of alkali earth metals, and then we'll wind up with the summary of the chapter. So please listen carefully, all of you. This is the last topic in this chapter. So with this, we are completing. With this lecture, we are completing successfully S block elements. So please listen carefully. Let us start now. Compounds of potassium. So potassium already we know as potassium can form superoxides. From potassium, rubidium, and cesium can form superoxides apart from their oxides and peroxides. So potassium superoxide combines sulfuric acid and forms potassium sulfate, hydrogen peroxide, and water. Just like sodium peroxide combines with oxygen with the dilute acids and forms hydrogen peroxide. In the same way, here also potassium superoxide combines dilute acids to form potassium sulfate, hydrogen peroxide. Apart from that, oxygen also will be formed. And potassium peroxide on reaction with sulfur, it forms potassium sulfate, which on heating strongly will form potassium sulfide. Potassium sulfide. Similarly, potassium superoxide on dissolving in water forms potassium hydroxide, hydrogen peroxide, and water, sorry, oxygen. So these two are common with superoxides, and with peroxides only hydrogen peroxide is formed. Potassium superoxide combines carbon dioxide and water, it forms potassium bicarbonate and oxygen gas. Similarly, potassium superoxide combines with carbon dioxide and forms potassium carbonate and oxygen gas. So these are the important reactions of potassium superoxide. And moreover, the potassium superoxide is paramagnetic in nature. It is paramagnetic in nature. And the oxygen state of oxygen is minus 1 by 2 here. So the oxygen state of oxygen is minus 1 by 2 in case of potassium superoxide. Same reactions rubidium and cesium also follows. So cesium peroxide on reaction with sulfuric acid, it forms cesium sulfate CH2SO4 plus hydrogen peroxide H2O2 plus O2. So same reaction rubidium, cesium and potassium. So for all the three peroxides, rubidium peroxide, superoxide also forms the same. Cesium superoxide also the form. What is the superoxide molecular formula? MO2. MO2 is called superoxide. The superoxide, the oxygen state of oxygen is minus 1 by 2 in superoxides. So all these reactions are very important. The byproducts are hydrogen peroxide and oxygen gas in superoxide, very, very important. Whereas in peroxide, the byproduct is only hydrogen peroxide, not the oxygen gas. Next, calcium forms. Now important compounds of calcium. Calcium forms important compounds given below. First one we have quicklime, that is also called as calcium oxide, calcium hydroxide, calcium carbonate, gypsum, plaster of Paris, and hydrated calcium chloride. So all these are the 6 important compounds of calcium. Let us see how they are prepared and what are the uses. So magnesium is extracted by calcination followed by reduction. Calcination followed by reduction. Electrolysis of anhydrous magnesium chloride takes place. So this is the extraction of magnesium. So calcination, what is calcination? It is a process in which I'm writing here calcination because you'll be knowing it in second year. So calcination is a process in which heating the ore strongly in the limited supply of air. The ore, heating the ore strongly in a limited supply of air. Limited supply of air is called calcination. Limited supply of air is called calcination. So reduction means you will be taking reducing agents such as aluminium, potassium. So alkali metals can be used as reducing agents. Alkali metals can be used as reducing agents as reducing agents because they are more electropositive than magnesium for the extraction of magnesium. for the extraction of magnesium. So please note down in your classwork this and both are complete topic. Next, calcination. By calcination, magnesium carbonate, as I told you, heating the ore strongly in the limited supply of air, we will get magnesium oxide along with carbon dioxide. Magnetite is the ore. Reduction. Magnesium oxide thus formed is reduced by electrolytic reduction or thermal reduction. So electrolysis of molten magnesium oxide is carried out by using carbon anodes and cast iron as cathode. So here magnesium oxide is being electrolyzed, then it forms magnesium is formed at cathode, magnesium is formed at cathode and oxygen gas is formed at anode. So you can see here thermal reduction can be made by using, as I told you, magnesium can be reduced by using aluminum, calcium carbide, carbon or silicon as reducing agents. So magnesium oxide on reaction with aluminum forms magnesium and aluminum oxide. So here aluminum is undergoing oxidation, magnesium oxide is undergoing reduction. So magnesium oxide is reduced to magnesium. Magnesium oxide is reduced to magnesium by the means of calcium carbide. Magnesium oxide on reaction with carbon will form magnesium plus carbon monoxide. Magnesium oxide on reaction with silk forms magnesium plus silicon dioxide. So all these reactions are very important. These are nothing but thermal reductions. Thermal reduction means at high temperatures. Only at high temperatures this reaction can be done. At high temperatures only. At high temperatures only, all these reactions can be done. So please make a note. Next continuation. So these additional topics are important for advanced level, as I told you. Next, electrolysis of anhydrous magnesium chloride. How the electrolysis is been carried out. Anhydrous magnesium chloride is prepared by heating MgCl2.6H2O. This is called salt of magnesium in a current of HCl gas and air. So magnesium chloride dot 6H2O on heating forms magnesium chloride plus 6H2O. Upon direct heating MgCl2, 6H2O forms MgCl2 MgOCl2, finally MgO, and MgO can be reduced by using reducing agents like such as aluminum, calcium carbide, silicon, etc., silicon dioxide, etc. So upon heating magnesium chloride 6H2O, there will be hydrolysis in two steps to give oxychlorides and then oxide as shown begun. So here this is called magnesium oxychloride and then magnesium oxide. So this magnesium oxide you can easily, for the electrolysis of anhydrous magnesium chloride, we add sodium chloride and calcium chloride. Why? This is very, very important point. For the electrolysis of this anhydrous magnesium chloride, we should add small amount of sodium chloride and calcium chloride and mixture proportion of 35 is to 50 is to 5, 15 is obtained. Mixture of proportion is taken. Why this NaCl and CaCl2 it adds is added because to lower the fusion temperature, because the melting point of magnesium chloride is very high. So to at this high temperature we cannot do electrolysis. We can write here the melting point of MgCl2 fusion mixture is very high, is high and difficult to conduct electricity and difficult to conduct electrolysis. To conduct what? Electrolysis. So to avoid this problem, to conduct electrolysis, so that's why here a small amount of sodium chloride and calcium chloride is added. Then the melting point of magnesium chloride will be decreased. So it lowers the fusion temperature. So why these two are added? To increase the conductivity and also to decrease the fusion temperature. The reactions involved are at anode from magnesium chloride, chlorine gas will go off, chlorine ions will go to anode and there it undergoes oxidation by gaining of electrons. Losing of electrons takes place. That's why you're writing that side plus 2 electrons and forms chlorine gas. And magnesium ions will go to cathode. At cathode, it gains 2 electrons and forms magnesium. So it is undergoing reduction. So at cathode, always reduction takes place, and at anode, oxidation takes place. Next, Downs process is used to obtain anhydrous magnesium chloride from seawater. Soil cement has a basic proportion of magnesium chloride dot 5 MgO dot XH2O. So these are the other compounds of magnesium. Soil cement has a basic composition of magnesium chloride dot 5MgO dot XH2O, and Dow's process is used to obtain anhydrous magnesium chloride from seawater. So after getting anhydrous magnesium chloride, we know how to do electrolysis of magnesium chloride. Anhydrous means without water. Anhydrous means what? Without water. So To the anhydrous magnesium chloride, small amount of NaCl and calcium chloride is added in the proportion of 35 to 50 is to 15. Why? To increase the conductivity and also to decrease the fusion temperature. To decrease the fusion temperature, these two are added because the melting point of magnesium chloride is high and difficult to conduct electrolysis. So if you add these two, what happens as an impurities, the melting point of magnesium chloride is lowered and then it is able to conduct. That's why after passing current, what happens? The magnesium chloride dissociates to form Mg plus 2 Cl minus ions and Mg plus 2 ions gains 2 electrons and forms magnesium, which is taking place at cathode, and the process is called as reduction. And Cl minus ions gains loses 2 electrons and forms, it goes to anode and lose electrons and forms chlorine gas, and the process is called as oxidation. So losing of electrons is called oxidation, gaining of electrons is called reduction. Next continuation. Extraction of calcium. Calcium is extracted by the electrolysis of fused mixture, only fused only. Fused mixture of anhydrous calcium chloride and potassium chloride in the ratio of 85 is to 15. The reaction involved are calcium chloride dissociates from calcium ions plus chlorine minus ions. So at anode, what happens? Calcium ions changes to calcium, and at cathode, so this is wrong actually. This is cathode. Always cathode only metal is formed. This is anode. So anode, yes, reverse is has been come. So this is cathode. At cathode, what happens? Calcium ion forms calcium atom, and chlorine gas forms chlorine. So chlorine ions forms chlorine gas at anode. So at cathode, oxidation reduction takes place. At anode, oxidation takes place. So this is the extraction of calcium from anhydrous calcium chloride and KCl, potassium chloride in the ratio of 85 to 15. Next, some examples. Now, potassium superoxide is carbon dioxide absorber and oxygen produced as shown. So yeah, this they are giving this balancing equation. So potassium superoxide combines carbon dioxide and forms potassium carbonate plus X. So the 3 moles of oxygen. How many moles of oxygen? 3 moles. Simply you can say 4 to the 8, 8 plus to 10. And here already 3 is there. So here 3 is there. So this becomes 3. 3 into 2, 6. 6 plus 3, 9. So here 4 twos are 8. 8 plus 2, 10. So somewhere it is given wrong. So potassium is 2 only here, 2K2CO3. 2K2CO3, then only it becomes wrong. So this balancing equation, we have to say 3 moles of oxygen gas, 3 moles. Simply I'll write here, KO2 potassium superoxide combined with carbon dioxide to form potassium carbonate plus oxygen gas. Now we can do balancing of this reaction. So since 2 potassiums are there, so 2KO2 plus carbon is 2 to the 4, 4 plus 2 6, and here it is 3. So it is 3 to the 6. So you can do balancing now. So 3 moles of oxygen. Apart from this, nothing else is found because H2 also will come here. And here also we'll get some other compound. So how many moles? 3 moles. Next continuation. Chemical A is used for water softening. Very, very important. It is used for water softening to remove temporary hardness. So A reacts with sodium carbonate to generate caustic soda. Caustic soda means NaOH. When carbon dioxide is bubbled to A, it turns cloudy. What is the chemical formula of A? Straight away we can say it is nothing but calcium salts because it is calcium hydroxide. It is what? Calcium hydroxide. Why it is calcium hydroxide? What happens? Calcium hydroxide is used for water softening and remove temporary hardness. When calcium hydroxide combines sodium carbonate, it forms sodium hydroxide along with calcium carbonate. This when carbon dioxide is bubbled to A, it turns cloudy. So when calcium carbonate is bubbled to A, it turns cloudy. So that is nothing but C. Answer C. Next continuation. The reaction of slaked lime with lime with chlorine gas gives slaked lime with chlorine gas gives only calcium oxychloride. This is also called as bleaching powder. What is this called? Bleaching powder. Calcium oxychloride. It is called bleaching powder. Option 2 only calcium chloride, a mixture of calcium oxychloride and calcium hydroxide and also water, and finally quicklime. Quicklime is calcium oxide only. So answer is a mixture of calcium oxychloride, calcium hydroxide, calcium chloride, and water. So the reaction of slake lime with chlorine gas gives mixture of bleaching powder, calcium hydroxide, calcium chloride, and also water. So very, very important. Please note it down. Next continuation. When carbon dioxide is passed into calcium hydroxide, a white precipitate is formed due to the formation of. When carbon dioxide is passed into calcium hydroxide, white precipitate is formed due to the formation of calcium carbonate. Simply, when calcium hydroxide is passed to, when carbon dioxide is passed into calcium hydroxide solution, a white precipitate is formed due to the formation of calcium carbonate. Next question. Lime water in aqueous solution gives white precipitate. Lime water in aqueous solution gives white precipitate by passing carbon dioxide. But the precipitate dissolves in excess of carbon dioxide. Why? Because it forms calcium bicarbonate. Forms what? Due to the formation of calcium bicarbonate, it dissolves in excess of carbon dioxide. What is the law of gypsum in cement? Gypsum is what? CaSO4 dot 2H2O. So what is its role in cement? Let us see now. So the role of gypsum in cement is nothing but gypsum decreases the rate of setting of cement. It decreases the rate of setting of cement, and it increases the time required for the setting of cement. It increases the time required for the setting of cement. So these two are the reasons why gypsum is used in cement. So it decreases the rate of setting of cement and increases time required for setting of cement. Actually, both are same because rate of setting of cement is that but time required for setting of cement. Next continuation. Organometallic compounds. What is this called? Organometallic compounds. Both, this is also very, very important topic. Both only beryllium and magnesium. Both beryllium and magnesium form many compounds with MC bonds, but for calcium, strontium, and barium, only a few are isolated. Such compounds that exist with a MC bond, M is called metal and C is called carbon, are called as organometallic compounds. The compounds which contains MC bonds, M single bond C are called as organometallic compounds. Example, Grignard's reagent, that is alkyl magnesium halide, was the first organometallic compound synthesized by Grignard and are called as Grignard's reagent. What is this R? R is called alkyl group. Alkyl group means CH3, C2H5 and so on. Alkyl magnesium halide. Alkyl magnesium halide is called Grignard's reagent. It is very, very important reagent, Grignard's reagent. It is used in synthesis of many organic compounds. How does it forms? When magnesium directly combines with alkyl halide. This RX is called what? RX is called haloalkane or alkyl halide. When magnesium combines with haloalkane, when magnesium combines with haloalkane, it forms Grignard's reagent. It forms RMGX. RMGX is called Grignard's reagent. This Grignard's reagent is used for synthesizing many organic compounds. Almost all the organic compounds, acids, alkynes, esters, alcohols, ethers, almost all the organic compounds can be prepared from Grignard's reagent. So that's why it is very, very important. So this is called as organometallic compound in which magnesium is combined with carbon. So how it is combined with carbon, you can see here CH3, this is called alkyl CH3, magnesium halide. So MgC bond is there. So MgC or MC bond are called as organometallic compounds. These are called organometallic compounds. Beryllium chloride on treatment with alkyl magnesium halide forms organometallic compound argon. BeCl2 plus 2R MgCl gives us BeR2 plus 2 MgCl2. So this beryllium chloride combines with Grignard's reagent and forms BeR2, that is diethyl beryllium, dialkyl beryllium. This BeR2 is called what? BeR2 is called dialkyl beryllium. Dialkyl beryllium. So this is also called organic metallic compound because beryllium, one side it is CH3, another it is CH3, for example. So this is also C bond is there. So that's why it is called organometallic compound. So beryllium Grignard compounds like CH3, BeCl are also possible. CH3, BeCl. So these are called organometallic compounds. So with this, we have completed completely S block elements. So now I'm sharing new slides for you so that we can continue with the new topic. So let us start now. Previous NEET questions. So in this now we are going to discuss previous NEET questions. Previous NEET questions from alkali metals. So let us start now. Question number one. So how will you get questions in NEET? We are just going to discuss now. First question. Which of the following statements is correct? Which of the following which of the following statements is correct? Option A, alkali metals alkali metals are less electropositive less electropositive than alkaline earth metals. Alkaline earth metals. Option B, alkaline earth metals. The alkaline earth metals are more denser and harder than alkali metals. Third option, alkali metals alkali metals are more denser and harder than are more denser and harder than alkaline earth metals. Alkaline earth metals. And fourth option, the first ionization energy, the first ionization potential, the first ionization potential of alkali metals, alkali metals is more than alkaline earth metals, alkaline metals. So what is the right answer? It could be. So it is nothing but directly easily we can say. Again, I repeat the statement. First statement, alkali metals are less electropositive than alkali earth metals. This is wrong because alkali metals are more electropositive than alkali earth metals. Alkali earth metals are denser and harder than alkali metals. This is the right answer because this statement is correct. Alkali metals are more denser and harder. This is wrong. The second ionization enthalpy of alkali metals is more than alkali earth metals, but not the first ionization enthalpy. So answer is B option. So that is first option, second option. Next question. Like these questions you'll get for NEET. This is NEET 2016 question. Next, second question, question number 2. Potassium is kept in option A, under cold water, under cold water. Option B, in ammonia. Option C, in alcohol. Option D, in kerosene. So we already know it is in kerosene. Why potassium is kept in kerosene? So that as all alkali metals are highly reactive, as all alkali metals are highly reactive, they are kept under kerosene. Since alkali metals are highly reactive with air, since alkali metals are highly reactive, highly reactive towards air. So they are stored under kerosene. They are stored under kerosene. So this is the answer. Next question, question number 3. Magnesium can be prepared. Magnesium can be prepared by heating. By heating. Option A, magnesium chloride with calcium oxide. With calcium oxide at 775 kelvins. At 1775 kelvins, they have mentioned the temperature also. Option B, MgCl2 with calcium carbide. MgCl2 with calcium carbide at same temperature, that is 1775 kelvins. Option C, MgCl2 with calcium hydroxide. MgCl2 with calcium hydroxide at the same temperature, that is 1775 kelvins. And finally, option D, MgO with calcium carbide. MgO with calcium carbide, magnesium oxide with calcium carbide at ordinary temperature. At ordinary temperature. Ordinary temperature. So what is the right answer now? So magnesium can be obtained by heating magnesium chloride with calcium carbide at 1775 Kelvin is the right answer because it will undergo reduction. So answer is what? Magnesium chloride with calcium carbide at 1775 Kelvins. Next. Question number 4. Let us start now. These questions are very important, so that's what I'm doing now. Question number 4. Nitrolim. Nitrolim, a nitrogenous fertilizer. A nitrogenous fertilizer is a mixture of option A, CaC2 and CaCN2, calcium carbonate and calcium cyanamide. Option B, calcium oxide and calcium carbide. Option C, calcium cyanamide, CaCN2 and carbon. And option 4, it is option D, calcium oxide and carbon. So we already know it is answer is C option. So calcium cyanamide and carbon, is the mixture is called as nitrolim and is used as a fertilizer. Next question number 5. Which of the following is strongest base? Which of the following is the strongest base? The following is the strongest base. Option A, it is aluminum hydroxide. Option B, it is magnesium hydroxide. Option C, it is calcium hydroxide. Option D, it is barium hydroxide. So answer is, since already we know, it is as we go down the group, the basic character increases. As we go down the group, the basic character increases. So as we go down the group, the basic character increases in a as we go down as we go down the group of first group and second group, that is group 1 and group 2, any group, basic character basic character increases. So when compared to first group, second group metals are less basic when compared to first group. But here they are given third group, that is aluminium. So that is 13th group. So definitely in between magnesium, calcium, and barium hydroxide. So answer is barium hydroxide, because as we go down the group, basic character increases. So barium hydroxide is the strongest base. Barium hydroxide is the strongest base. Next question. Question number 6. When magnesium ribbon, when magnesium ribbon is heated to redness, is heated to redness in an atmosphere of nitrogen, in an atmosphere of in an atmosphere of nitrogen, and subsequently cooled with water, and subsequently subsequently cooled with water subsequently cooled with water, the gas evolved is option A is nitrogen, option B, this question is very important, option B it is ammonia, option C it is hydrogen, and option D it is carbon dioxide. So answer for this is, the answer for this is, it is nothing but, since already we know when magnesium ribbon is heated to redness, when magnesium combines with nitrogen, 3 moles of magnesium combines with nitrogen and forms magnesium nitrate, Mg3N2. This magnesium nitrate subsequently cooled with water, combination with water, it forms ammonia gas along with magnesium oxide. So ammonia is formed. What is formed? Ammonia. Next question. So next NEET questions, NEET 2017 question now. Question number 7. Ionic mobility. Ionic mobility of which of the following alkali? Which of the following alkali? This is NEET 2017 question. Which are the following alkali metal ions? Alkali metal ions is slowest when an aqueous solution of an aqueous solution of their salts put under electric field, put under an electric field. So this question is very important. So option A it is sodium, option B it is potassium, option C it is rubidium, and option D it is lithium. So what is the right answer? So it is nothing but ionic mobility. Since lithium has high heat of hydration, since lithium has high heat of hydration, it is more soluble in water, heat of hydration. So it will form and the strongest reducing agent, strongest reducing agent, strongest reducing agent. So ionic mobility is lowest for lithium. Lithium. It is answer is what? Lithium. Very, very important. This type of questions will come definitely for every year. So that is NEET 2017 question. Now next question. Question number 8. This is NEET 2016. The suspension of slaked lime. Slaked lime is what? Calcium hydroxide. Slaked lime in water is known as option A. It is lime water. Option B. It is quicklime. Quicklime means calcium oxide. Lime water means calcium carbonate. Option C. It is milk of lime. It is milk of lime. And option D. It is aqueous solution of slaked lime. Aqueous solution of slaked lime. Aqueous solution of slaked lime. So what is the right answer? It could be. So when slaked lime is suspended in water, the suspension of slaked lime in water is known as milk of lime. It is called what? Milk of lime, because lime water turns milky due to the formation of calcium carbonate. Due to the formation of calcium carbonate, it is also called as milk of lime. Next, in context with beryllium. In context, this is NEET 2016 question. In context with beryllium, which one of the following? Which one of the following? Which one of the following statements? Which one of the following statements is incorrect? Incorrect means we have to identify the wrong statement. Incorrect. Option A, it is rendered passive. It is rendered passive by nitric acid. Option B, it forms beryllium carbide. This already is correct because we know beryllium will form beryllium carbide. Option C, it's salt, it's a salt rarely hydrolyzed. It's a salt like barium chloride, etc. It's salts rarely hydrolyze. And option D, its hydride is electron deficient. Its hydride is electron deficient. Its hydride is electron deficient. And polymeric. This is also correct because beryllium hydride is polymeric in nature. So the wrong option is its salts are rarely hydrolyzed. It forms beryllium carbide and is rendered passive by nitric acid. So beryllium salts are not rarely hydrolyzed, they hydrolyze 100%. So answer is third option, that is C. This is the wrong statement. Remaining are right statements. This is a wrong statement because beryllium compounds, beryllium salts readily hydrolyze, not rarely hydrolyze. They readily hydrolyze. Next question. This is NEET 2015 question. Question number, I hope it is 10. Yes. Question number 10 now. This is NEET 2015 question. The function of sodium pump. The function of sodium pump. The function of sodium pump is a biological process. Is a biological process. operating in each and every cell of all animals, operating in each and every cell of all animals. Which of the following, which of the following biologically important ions, biologically important ions, biologically important ions is also a constant of this, is also a constituent. Constituent means part of this. Option A, it is calcium ions. Option B, it is magnesium ions. Option C, it is potassium ions. And option D, it is iron ions. So we know already the biological importance of sodium and potassium. Sodium and potassium. So in sodium pump, potassium is also present. Potassium is also present. Next. So answer is potassium ions. Question number 11. This is NEET 2015 question. Solubility of alkaline earth metal, alkaline earth metals, sulfates in water, in water decreases in the sequence, decreases in the sequence. So they are asking decreasing order of solubility. Option A, that is also only sulfates. Magnesium greater than calcium, greater than strontium, greater than barium. Option B, calcium greater than strontium, greater than magnesium, greater than barium. Option C, strontium greater than calcium, greater than magnesium, greater than barium. Option D, barium greater than magnesium, greater than strontium, greater than calcium. These are the sulfates. So magnesium, calcium, strontium, barium is the order. So magnesium sulfate is more soluble in water when compared to calcium sulfate, strontium sulfate, and barium sulfate. So barium sulfate is almost insoluble in water. That is sparingly soluble in water. So answer is first option. Magnesium sulfate is more soluble than calcium sulfate, than strontium sulfate, than barium sulfate. So please note on this order, very, very important. Next question. So question number 12. On heating, on heating, which of the following gases, which of the following, on heating, which of the following releases carbon dioxide most easily? Most easily they are asking. Means from everything we'll get, from all the options we'll get carbon dioxide, but which will form most easily the carbon dioxide molecule. First is potassium carbonate, second is sodium carbonate, third is magnesium carbonate, and fourth is calcium carbonate. Option D, it is calcium carbonate. So answer is magnesium carbonate. Magnesium carbonate readily gives out carbon dioxide easily. Very, very important. Like these simple points we'll not remember. So that's why it is very important. Please note it down. Next question number 13. This NEET 2012 question. sorry, 2011 question. Which one of the following, which one of the following is present, is present as an active ingredient, active ingredient in bleaching powder, in bleaching powder for bleaching action, for bleaching action. Option A, calcium oxychloride. Option B, CaO2Cl. Option C, CaCl2. And option D, CaOCl2. Which one of the following is present as an active ingredient in bleaching powder for bleaching action? So it is nothing but oxygen, because bleaching powder dissociates to form oxygen. So answer is first option. Active ingredient. Oxygen and chlorine only active ingredients. That's why we have kept bracket for it. Next question, question number 14. Very, very important. This is Neet 2010 question. Which one of the following alkali earth metal? Which one of the following alkaline earth metal sulfate, earth metal sulfates has the hydration enthalpy higher than, has the hydration enthalpy, has the hydration enthalpy higher than, higher than the lattice enthalpy, higher than the lattice enthalpy. Option A, it is calcium sulfate. Option B, it is beryllium sulfate. Option B, it is beryllium sulfate, beryllium sulfate. And option C, it is barium sulfate, is slightly soluble in water. And option D, it is strontium sulfate. So among sulfates, which is having more dissolution, means which can dissolve readily in water, they are having hydration enthalpy more, has a hydration enthalpy higher than lattice enthalpy. Because if hydration enthalpy is greater than lattice enthalpy, the substance is soluble. If the lattice and the high hydration enthalpy is greater than lattice enthalpy, the substance is soluble. This we already discussed in the lectures. So answer is beryllium sulfate. Beryllium sulfate is having high hydration enthalpy than lattice enthalpy. That's why beryllium salt sulfate is more soluble in water when compared to other sulfates. Next we'll get for magnesium. Next, question number 15. Properties. This is Neet 2010 question again. Properties of other alkaline earth metals. Properties of the alkaline earth metal. Earth metal. Properties of the alkaline earth metals that increases, that increases with their atomic number is, with their atomic number, atomic number, with their atomic number is option A, solubility of their hydroxide in water, solubility of their hydroxides in water. Option B, this question is also very important. Option B, solubility of their sulfates in water. Solubility of their sulfates in water. Option C, ionization energy. And option D, increases, they are asking, not decreasing, electronegativity. So what happens if you take into consideration electronegativity? Electronegativity decreases down the group, but they are asking increases with their atomic number. So definitely should be either 1 and 2. And solubility of the hydroxides and solubility of the sulfides. So we know sulfides decreases within water and solubility of the hydroxides increases in water. So answer is A. Option A is the right option because solubility of the hydroxides increases in water. Increases with the increase in atomic number. So magnesium hydroxide is less soluble than calcium hydroxide. Calcium hydroxide is less soluble than strontium hydroxide. Strontium hydroxide is less soluble than, like this it goes on, barium hydroxide. Next question number 16. These are all previous NEET questions only, so that you can understand in what type of questions you are going to get. So all the trends are important. Question number 16. This is NEET 2009 question. In the case of alkali metals, in the case of alkali metals, in the case of alkali metals, the covalent character, the covalent character, the covalent character decreases in the order, decreases in the order. Usually all the alkali metal compounds are ionic in nature. Only lithium compounds are covalent. So they are asking decreases in the order. Option A, MCl, that is metallic chloride of first group, M iodide greater than MBr. Within the halogens they have given greater than M fluoride. So it is very simple. Next, option B, metallic fluoride greater than metallic chloride greater than metallic bromide greater than metallic iodide. Next, decreasing the covalent character. So metallic fluoride greater than metallic chloride greater than metallic iodide greater than metallic bromide. Next, where M can be any alkali metal. Next, we have metallic iodide greater than metallic bromide greater than metallic chloride greater than metallic fluoride. So in case of halogens, the right option is metallic iodide. Sodium iodide is more covalent than sodium bromide, sodium chloride, sodium fluoride. Similarly for lithium, any metal. So where M is equal to any alkali metal. So answer is M is equal to alkali metal. So answer is fourth option, that is metallic iodide is more covalent than metallic bromide, is more covalent than metallic fluoride, more covalent than metallic fluoride, and so on. Next question. Next question now. Question number 17. The alkali metals, the alkali metals form salt-like hydrides. Salt-like hydrides. The alkali metals form salt-like hydrides by the direct synthesis, means by the direct combination, by the direct synthesis at elevated temperatures. At elevated temperatures means with increasing temperature. Elevated temperatures. The thermal stability of these hydrates follows the order. The thermal stability of these hydrates decreases in which of the following orders? Which of the in which of the following in which of the following orders? Option A, cesium hydride greater than rubidium hydride greater than potassium hydride greater than sodium hydride greater than lithium hydride. Next, option B is potassium hydride greater than sodium hydride greater than lithium hydride greater than cesium hydride greater than rubidium hydride. Next, option C, it is sodium hydride greater than lithium hydride greater than potassium hydride greater than cesium hydride greater than rubidium hydride. And fourth option finally, lithium hydride greater than sodium hydride greater than potassium hydride greater than rubidium hydride greater than cesium hydride. So it follows a general trend only. So the right option is, so alkali metals form salts like hydrates by the direct synthesis at elevated temperatures. That thermal stability decreases in which of the following orders? That thermal stability decreases since thermal stability decreases down the group. Thermal stability of hydrates, thermal stability of hydrates decreases down the group, decreases down the group. So the answer is lithium hydride is greater than sodium hydride, greater than potassium hydride, greater than rubidium hydride, greater than cesium hydride. So like these questions you'll get for NEET. Next question, question number 18. Beryllium carbide and calcium carbide. Beryllium carbide and magnesium carbide. Beryllium carbide and aluminum carbide are called beryllium carbide and aluminum carbide are called as option A acetylides, option B methanides, option C alkalides, alcohols, and option D hydrated isomers. So in order to keep hydrated isomers, we can say hydrated enthalpies. So beryllium carbide and aluminum carbide are called, as we already know, beryllium carbide on hydrolysis forms methane gas. Yes, I'm giving balance. I'm not giving balance equation. Similarly, aluminum carbide also on hydrolysis forms methane gas. So the answer is methanides. So beryllium, since beryllium carbide and aluminum carbide on hydrolysis forms methanides, they are called as methane gas. They are called as methanides. They are called as what? Methanides. Like these questions you are going to get in the examination. Next question. So these are the important questions so far we have discussed. Now, these are all the previous NEET questions we have completed. Next, I'm going to discuss the summary of the chapter. Then we'll end up this session. Now coming to summary of the chapter. Summary of the chapter. So first, general properties. General properties, both physical both physical and chemical of alkali and alkaline earth metals. These are very, very important. Alkaline earth metals, alkaline earth metals option. Next we have preparation, preparation and properties of properties of sodium, potassium, lithium in first group, and beryllium, magnesium, and calcium compounds. Next, we have oxides, hydrates, hydrates, sulfates, hydroxides, and carbides of group 1 and 2. Of group 1 and 2. That is alkali and alkaline earth metals. So, and finally, we have extractions of sodium, potassium, extractions of sodium, potassium, magnesium, and calcium. And fifth point, we have biological importance of biological importance of biological importance of sodium and potassium, and here magnesium and calcium. So these are the topics we have in this entire chapter. So all the topics, especially first topic, third topic, is most important, and also first, second, third. If you do all the three topics thoroughly with so many questions, easily you can understand and easily can do questions from the exam. For the exam from extraction and biological importance you may not get, but from these three topics only we get more questions. So preparation, properties of compounds of first group and second group, oxides, hydrates, sulfates, hydroxides, and carbides of first group and second group, and general physical and chemical properties of alkaline and alkaline earth metals are most important. At least from each part, you do 50 questions each, so that if you do 150 questions, this chapter you will get master in it. So do thoroughly, because from for NEET, it's exactly you get one or two questions, and for even mains also you'll get one or two questions from this chapter. So very, very important. So please do it compulsory. With this, I'm ending this session. So please follow what we discussed. This chapter is finished. That is S block group 1 and 2 is finished. With this, I'm ending this lecture. Thank you.